So my name is Andrew Henkart, and I'm a senior consulting engineer with the Deepfield business unit. And I've been working with networks and IP for the last 20 years, and for the last 10 years, I've mostly been focused on network analytics and security, mainly in DDoS. And today what I'm going to talk about is the challenges that our customers, whether they're carriers or large enterprises or CDNs, run into in getting visibility into their network, and specifically end-to-end content visibility. Right? This is a difficult problem to solve. So the challenge that we see is that our operators need to understand what kinds of cloud services are being consumed. Right? If we think about what Craig said earlier about CDNs, all of this traffic is being delivered by CDNs. So how do you understand what that traffic is unless you have some way to map it and really understand what that content is? Right? So what we've developed is a proprietary technology called Cloud Genome. And what Cloud Genome does is it decodes the cloud services and CDNs within your network and tells you what those applications are, all out of band without the use of inline probes, right? And I'm going to talk about what Cloud Genome is and how it works. But essentially what we're doing is we're decoding the different applications and cloud services that are running on your network, on the customer's network, so that they can understand what kind of content is being delivered and being consumed on the network. So whether it's Netflix or YouTube or Pandora or Facebook or Twitter, all those different applications, we're able to decode that in software and give visibility into what kind of content is coming in and out of the networks. So this is great. Traditionally, what people had done to get this kind of visibility is to use inline DPI, right? People would install DPI maybe at the peering edge, or they might install DPI down in a market somewhere. But it's really expensive to do that, right? As the network increases, the capacity increases, you have to be continually buying more DPI, you have to be continually deploying it, operating it. It gets really, really expensive and it doesn't scale very well, right? So by doing this all in out of band in software, we're able to scale a lot better than DPI at a much lower price point, right? So the second thing that people need to understand, the operators need to do, is they need to understand how this content is getting to them. So understanding just how much content is on your network isn't good enough anymore. I need to understand how is this content being delivered to my network. Is it coming through some kind of direct CDN connection? Is it coming through paid transit? Maybe it's coming through some kind of settlement-free peering. But the operators need to understand how that content is entering their network and is it in the most optimal place. So Deepfield helps us solve that problem, helps us understand not just what the content is, but where it's entering the network, right? And thirdly, what customers need to know is how is this overlaid on the topology of my network? Where is this traffic going, right? I now know what it is, understand where it's originating, understand how it's getting in my network, but where is it going? Is it going to a specific market? Is it going to a specific region? If you're an enterprise, is it going to a specific customer within your network? Or maybe a data center or a top-of-rack switch, something like that? You need to get the end-to-end visibility. And that's what our Deepfield Cloud Intelligence does, is it gives our customers end-to-end visibility. Yes?
So how are you folks addressing the issue that goes on with obviously HTTPS and TLS for the app stack? I mean, you can use address space to be able to determine who the classic cloud app and services are, but is there anything else additional that you're doing in terms of metadata tagging and information you're sharing across?
Yeah, so it goes to Cloud Genome. So we don't care if it's encrypted or not, right? So traditionally DPI would kind of break down in a lot of those, looking at signatures.
Fingerprinting, just like DHCP.
Yeah. So we understand, like, so for instance, we have a map of where Netflix OpenConnect servers live and Akamai servers, or how a specific cloud application is being delivered, what IPs they're using, what kind of server. We have a ton of information. All of that information gets distilled into our Cloud Genome data feed, which our customers can pull in, and then we can use that to classify the different flows in the network. So we can actually tell you, like, hey, how much Facebook is encrypted versus unencrypted? We can tell you that, right? How much is V6 versus V4, those types of things. Right? And I'll explain how that works in the next slide, actually. I'm going to point it this way. So what are we doing? How do these kind of tools work, right? How does Deepfield work? Well, the first thing that we need is data, right? So we get data from your network. So traditionally, this is your routers, your switches, anything that could export some kind of NetFlow variant, whether it's NetFlow or IPFix, SFlow, JFlow, CFlow, some kind of flow information, right? And we ingest that data. We also take in SNMP data. So we need to have a conceptual understanding about what your routers look like, what are the interfaces, what are their names, right? Those types of things. We also take in BGP. So we have some notion of origin AS AS path, BGP communities inside of your network, that kind of information. We can also take in DNS information, right? So if you have recursive resolvers on your network, we can ingest that DNS information, and that really gives us a lot of information because now we can kind of see what the client actually requested when they hit a particular IP address. And so we can combine that with some other data sources and really get a really rich picture of what's going on in your network. We can also take in like AAA information if you have a subscriber network. We can take in any other kind of custom information, like let's say you're an enterprise and you have a whole list of customers that you want visibility into what they're doing on your network and how they're routing traffic. We can ingest a data file that has a mapping of all of that. And then we can use all this data to give you visibility into your network.
On the DNS side, you can do dot and do also now?
I'm sorry, what?
You can do dot and do on the DNS side?
Sure, yeah.
Okay.
So we take in all of this information and we ingest it in the Deepfield core platform. So that's kind of our core big data code, right? So that's the code that ingests this data, correlates it. We take all that data in, we correlate it every 10 seconds, and then we provide you visibility in that data. But we also correlate it with our cloud genome. So this is the data file that maps and tags every flow that we see in the network with what the cloud application was and what if it was delivered by a CDN, what the CDN is that delivered it as well, right? So we get all this information. At this point, we have a ton of information in our system. We store that in our platform, and then we present it to our customers through a web UI and a fully open REST API. And in fact, the web UI is using the REST API under the hood to pull that information out.
Do you have any direct partner peering with like a Cloudflare or like, Fastly or anyone else where you don't have to have abstractions of fingerprinting it? You can get directly from them a feed?
You're talking about for Cloud Genome, like the mapping of it?
Yeah.
So we do it all independently. Okay. So we don't ever harvest data from anyone, or it's our own thing. We go out and we discover what cloud services and CDNs are running, what that infrastructure looks like, right? It's all on us, right? So we don't go through. But in some cases, maybe that might be something we should look at. But for now, it's all us. Yeah.
Is Deepfield a cloud service that you guys offer, or is it premises?
That is a great question. Let me address that right now. So Deepfield is a software solution. So it can be installed in the cloud, or it can be installed on premises, right, with your own hardware, right? If you want to provide us hardware, that's great. We'll install it on there. And it's all in software, right? All of this is done in software. So yep, either way.
And is it outside your network as well, or is it only assets that you have? So when you go out to a Netflix, you can see that flow.
Yeah, so we're just getting telemetry from your routers, your network, right? So it's your NetFlow that you're exporting to us, your SNMP, your BGP. Now we can see what kinds of places you're going based on BGP, like we know what origin ASNs are serving traffic, we know what AS path you're taking, those types of things, but it's just your network that we're giving you visibility. So every one of our customers that has a deployment, we're just telling them about what is going on inside their network.
Is there plans to go into where you have your equipment as a transit or a service provider and pulling kind of my data that's transitioning your networks?
We've talked about like a partnership kind of deal, like where you would share information with other people.
Yeah.
We talked about that, but it's most people want to hang on to their data. They don't like to share their data, right? They don't want to say, hey, I have data from this other ASN and let's share information, that kind of thing. Most people are very proprietary about, this is my data, I want it to stay within my deployment, right?
And it's about a license, for example. Is there some license that needed to install or something like that to make a flow, to capture the flow? So all of this is happening within the Deepfield platform, which obviously you need to have a license to run. But all of this data is open data. So NetFlow is within your routers. It's within the Nokia routers. It's within Juniper, Cisco. All of the major router vendors, right, can support lots of different versions of NetFlow. Obviously, SNMP, every major router vendor supports SNMP, BGP. DNS is actually, we have some code that we wrote to do the DNS piece. It's actually on our GitHub site, so you can actually go look at that. It's open source. So all this is open data.
I'm curious about the SNMP statement only because of its traffic profile. Like, what are you using SNMP for?
So SNMP we use to walk the router. We do an if index walk to understand the interfaces. Okay. And then we do octets, so we get in and out octets, and then we also get the interface descriptions and if aliases, if names, all that kind of information.
So it's just supporting information.
It's basically metadata to help us make decisions about
what different interfaces are on your router and how traffic is entering and leaving. So we can look at it and say, hey, this is an external peering interface, and oh, it's to level 3 or something, right?
And on that, you can have other vendors feeding in information into this?
Like
Cisco routers can...
Oh yeah, absolutely. We're completely vendor agnostic. Yeah. Any router vendor that supports some version of Flow, whatever that might be, we'll happily take it.
So if you're dumping Flow into like a Splunk or something, can you pull it out of there as well?
Yeah, if traditionally in that case, what we ask people to do is to tee that flow to us to ingest. So if you have let's say you have like a Samplicator instance, or you have another collector that's collecting flow, you can configure that collector to tee that flow to us, and then we'll ingest it, right? So you don't have to have multiple entries in your router to export to multiple destinations. That's typically what we do with that. And so I think maybe I'm running a little bit short on time here, so I'll touch on this real quickly, and then we'll get to, I want to make sure we have time to get to the live demo, right? So these are kind of the different applications and different problems that Deepfield is solving. The first one is really to have a core platform that can ingest all of your data, right? That's actually a tough thing to do, right? We have customers that have thousands of routers that have millions of flows per second, and to be able to consume all of that data, correlate it all in real time in 10 seconds, and present that information to you in near real time is a really tough problem to solve. Also, scaling out horizontally, right? So we can add more servers to scale out our cluster horizontally to scale if we need more compute capacity, right? So this in and of itself is actually a really tough problem to solve in the industry, right? Is just getting it to ingest all that data, correlate it all in real time, and present that data. So then on top of that, we have a couple different verticals of applications that customers can install to solve different problems, right? So number one is insight. Give me visibility into my traffic. So that's our cloud intelligence product. That is the sites, the services, the CDNs, the kind of end-to-end visibility I showed you in the first slide. That's cloud intelligence. Number two is performance, service intelligence. So this is, we're looking at, we're actually able to decode over-the-top video streams within the NetFlow data. We're able to count those streams, and then we're able to approximate an ABR, an average bit rate, for those streams. And we can do that for any place in the network that we're gathering data. So we can tell you what your average bit rate and the number of streams are coming through a particular peer, or on a particular router or interface, or a particular market, or maybe CMTS. And so you're able to pinpoint if you have specific issues at a specific spot, right? You can actually see the ABR dropping.
You're getting that out of Flow data?
We're getting that out of Flow data. Right. Third is security, right? We have all the data we need to do DDoS detection and DDoS mitigation. And so we're doing that as well. And we're going to talk more in another section about Defender, more in depth. And then last but not least is monitoring and alerting, right? So again, we have all this data. We have a long history of this data. What we can do there is we can operationalize that data, help you to operationalize that data, right? So I often get asked by the operations guys when I go talk to companies, and they say, you guys have a ton of data. How can I operationalize that data? I don't want to have somebody just sitting at a monitor, looking at cool things, but I want you to tell me when something changes. That's what that product is doing. You're able to enter in any query you want, baseline that query, and then send a proactive alert when that query deviates statistically, right? So think of it almost as like a genericized Defender engine, but across any dimension, any query, and any possible combination of dimensions. It's really, really powerful. So let's jump into a demo. So here we have, this is our Deepfield Cloud Intelligence. This is what the product looks like. So as you can see, it's very rich graphically. There's lots of different reports that you can drill into, lots of different information. We have some big data visualizations. Right at the click of your fingertips, you can get all kinds of information here, right? So visibility is really key. Right off the bat, we can see how much total traffic we have, ingress and egress, and P95. So we have lots of different measures. So whether you're doing capacity planning and you want peak, or you're doing some kind of billing application, you want P95, you can get either one of those out, right? We've talked a lot about dimensions, but let me just kind of show you what a dimension is, because not everyone's going to understand what I mean when I say a dimension. So a dimension is just a way to look at traffic and to classify traffic on a network, right? So it's things like origin ASN, AS path, or like router, interface, those kinds of things. Those are all ways that we can tag a flow. We can say this flow came in on this router, this flow came in on this interface. It's IPv4 or v6. And that's actually a really good one to understand, right? So if I click on IP version is just a dimension in the system. And it has two positions, right? IPv4 or IPv6. So every flow that comes in, we tag either that flow with either IPv4 or v6, and we do this every 10 seconds for every flow that we see in the network across every possible dimension, and we tag every possible combination of dimensions as well. So what does that mean? So it means if I wanted to see how much IPv6 I had on a specific router or a specific interface going to a specific market from a specific origin ASN, I can do that multidimensional query because we've captured that data for every possible combination of dimension. So it allows you to find whatever kind of needle in the haystack you want in the data.
It'll do that for tunnel transport too. So if you're dealing with issues where you're kind of,
Well,
that's a big problem with CMTS, right? Is that NAT64, DNS64, and the sort of the burden that it puts on the network. You're trying to discover, am I overloading particular network interfaces because I'm redirecting too much traffic?
right.
Because of DNS64, NAT64 on an overload case, right?
Yeah, I mean, so we'll only see whatever traffic we see in NetFlow, right? So if it's in some kind of tunnel, if it's encapsulated or something, we may or may not have that information to see that.
Yep.
But if we have the data in our system, you can absolutely see what that traffic looks like, right? So let me give you a couple examples, right? So we talk about cloud applications and understanding how to engineer content. So let's dive into the sites application here. So this is our cloud genome data. So this is the NetFlow data. Once it pulls up, this is the NetFlow data that we've classified for the different services. So here we can see 88 gigs at peak for any traffic that's matched one of these sites. We can see what it looks like over the different days. But the real meat of this is down here when we start looking at the actual applications. Right? So here, again, this is an eyeball network. So this is kind of what you would expect, right? You would expect Netflix and YouTube and Google and Apple and Facebook and Hulu and all those kinds of things. We're doing all of this matching with Cloud Genome, all of this out of band, without DPI, in software, just with NetFlow, and the other couple data sources, right? So this is really powerful stuff, right? We can see peak, average, P95, but then we can easily just click and drill in on this and see what this looks like, right? So I can click on YouTube here, and we're going to go in and drill in on YouTube. So here's my YouTube traffic for the month of February, right? 16.9 gigs total, of which almost all of that is received, which is kind of what you would expect. About 114 megs of sent traffic. And we can see what it looks like day over day, right? So here's the weekends, the little blue bar. This little blue bar, you can't really see it on the screen here, but this blue bar represents there's like a blue window here that represents the weekends. So you can see, on the weekends, people go off and do things. They do other things besides watch YouTube. And then during the week, they come back and watch YouTube, right? So we also have the notion of IP cardinality, so understanding what kinds of unique IP addresses we see on the network, and we're able to count those IP addresses. So not only are we seeing the traffic, but we're able to see how many people are actively doing something on the network, right? So here we can see for the month so far, 8.6 thousand people at peak were watching YouTube. So that's really cool to know, right? How many people are actually participating in a specific cloud service, especially if that thing is starting to consume a lot of data on your network. You need to understand, like, hey, how is this thing growing? What is this going to look like in 1 month or 2 months? Those types of things. So here I can see 3% of my subscribers are consuming 19% of my traffic on my network, just for YouTube, right? So what happens if that number goes to 4 or 5 or 6% of my subscribers? What is that going to do to my network, right? It's helpful to understand that.
And how long is the information held for?
So we will hold it for as long as we have disk space. And if it's your server, you can give us infinite disk space if you want, right? So it's really up to you or the customer for how long they want to keep it, right? Down here, we see some of the other dimensions in the system. So now we can get a really good idea of where YouTube is originating and how it's entering my network and how it's getting to me. So here I can see YouTube by path. So we actually have an understanding of what your network looks like. So we understand what IPs are on net and what IPs are off net. So they have some caches here, some Google Global Caches, right? So we can see the CDN, it's 100% GGC, Google Global Cache. And so we can see that this on-net traffic is originated by on-net CDN, by an on-net Google Global Cache, right? We can also see how much is off-net. So the traffic that's not originated there, we can see there's 8.4 gigs of traffic that's coming from some ASN outside the network that's coming into the network. So here I can see that that's 99.8% of the off-net traffic is being originated by origin ASN 15169, which is Google's ASN.
Given that you have all this data, are you doing like any sort of normalization and statistical deviation to say like, this is a pattern last week, the pattern this week is like X delta above?
So that's what operational intelligence, that's a great question. That's what operational intelligence will do. So if you wanted to look at, let's say, I want to look at all my peering traffic or my router traffic, and I want to baseline this traffic and then alert when something happens, that's what operational intelligence will do.
And you can say how many standard deviations?
Yeah, 3 standard deviations, 2 a static threshold, percentage. It's really, really custom. You can say, I want to look at today versus last week at the same time versus 2 weeks at the same time. I mean, it's really flexible. It's really, really pretty amazing, right? We can see that this is 100% video. And then we can also see where this traffic is coming in. So if you go back to the first slide I had, where we had all of the kind of names on the left, that's the origin ASN side. And then the peer is how it's entering. So of the off-net traffic, 99.3% of it is coming in through a direct peering relationship with Google, right? Which makes sense. But there's a little bit coming asymmetrically through a couple other providers, right? It's not a lot of traffic, but there's a couple other ASNs that are peers that traffic is coming in, right? So that's good to know for content engineering. And I have another example that I'll give you here in a second. But you also want to know, where is this traffic going? Who is consuming this traffic? Is it a specific customer? Is it a specific CMTS or a market or a region? We can break this down. This is a custom dimension in this system that the provider whose network this is configured to track this, right? So we can tell you what market. Is this traffic going to Denver or Chicago or New York or customer A or customer B, that kind of thing. So you really get a full end-to-end visibility of where it originates, how it's entering, and where it's going. And we could have added probably 10 other dimensions in here if you wanted to, right? So we could put IP version in there, for instance, right, to see how much is IPv6 versus v4, or application port or some other things, right? This is just what's configured. Let me give you another quick example here. So let's flip it around a little bit and let's go look at CDN, traffic by CDN. So instead of looking at a specific site and seeing it delivered by lots of CDNs, let's go look at a CDN and see what kind of sites and services and what they're delivering, right? So here we can see all the top CDNs on the network. So GGC is Google Global Cache, so that's all the Google stuff. We have OpenConnect, which is Netflix. We have CloudFront, Facebook, Apple, Akamai, Level 3, all the kind of top CDNs you would expect there. So let's go click into Akamai, because Akamai can deliver all kinds of traffic. So here we can see for the month, 6.7 gigs of Akamai traffic. And here we can see the peak received, peak sent. And we can also see the other dimensions in the system of how Akamai is delivering traffic. So let's go see what kinds of things Akamai is delivering here. So Akamai is delivering, you know, we can see it's delivering some Microsoft, some Azure, Apple, Nintendo, Adobe, right? So this is important to know, like if there's like some kind of live streaming event coming up, like the Super Bowl or NCAA, or some other event where there might be kind of a flash crowd, something going on, like you know, a new Game of Thrones might come out, or some other event like that, right? You need to understand what CDN is delivering that content, how it's delivering me that content, and do I expect to have any kind of issues with peering or my backbone, those kinds of content engineering questions. Is it going to be delivered by something on net? Is it going to be delivered by something off net? Those types of things, right? So we'll go back one. What's really interesting here is that if we look at Akamai by origin ASN, I have 2 ASNs. I have 16625, which is delivering about 62% of the traffic. And then I have ASN 20940, delivering another 20%. So between those two, it's 80-something% of the traffic is being delivered by those 2 Akamai ASNs. But if I look at my peers that traffic's entering in on, 80% of it, almost 80% of it is coming through AT&T 7018. So that's paid transit. So they're paying for that, right? So that represents an opportunity to optimize the traffic to get better performance. And it also represents a cost savings, right? They're paying for that traffic. What's interesting is that they actually peer with AS 20940, but that traffic's not coming in AS 20940. So something's going on there. Now, I don't know what that is. It could be, I mean, maybe it's a capacity issue, maybe it's, you know, I don't know what's going on, but that represents an opportunity to optimize that traffic and save money because that traffic is asymmetric, right?
It also tells you when you should be getting their caching services on site. Right?
That's right. Yeah, that's right. And so we can also see where Akamai is being delivered internally, right? So I have a lot of customers that use this exact kind of report to say, what market do I need to put an Akamai cache in? Or any cache, really.
And once they have a cache in a market, is that cache delivering traffic locally, or is it traversing my backbone and using, like, do I have traffic from an Akamai cache maybe in California or some other cache, right, as an example, using my backbone and delivering it on the East Coast somewhere? You see that a lot, actually, right? Where because of DNS, maybe they have a different DNS resolver that they're using configured, and so DNS redirects them to some other cache, right? Those kinds of things. You can tell that with this kind of tool.
Can you drill down into some of these and figure out the whys on why that Akamai is coming in on an AT&T instead?
I don't know. I mean, we could drill into it a little bit and see, but it's really hard to say because that's Akamai dumping traffic off to another transit ASN that's going through AT&T. So because I'm not part of this network, I'm not a network engineer on this network, I don't know necessarily. But they would probably know, right? They would know, they'd say, go to the peering guy and say, hey, what's going on with this? Talk to the network engineers. And then they meet with these guys regularly. They might go and say, hey, let's go meet with, Akamai or some other provider and figure out what's going on, right? So, but yeah, you can keep drilling in as far as you want, right? You could go in and drill into AT&T, you could go drill into another peer, you could go do, 3 or 4 different dimensions, those kinds of things.
All the way down to like an interface? Or is this kind of above that?
No, we could do that. I'd probably go about it a different way. I'd probably go through I'd probably go do it this way, right? Where I could go through and say, I want to look at an interface, and I want to look at some specific interface. Now, I don't know what interface is going to have traffic on here because there's a bunch of them. But then I would just pick whatever interface I wanted to, hit run, and then I'd pull that up and see that traffic on that interface, right? And then you could continue to add different dimensions. So let's say you found like AE 10.0 maybe is an interface that has a bunch of traffic on it. Then you could say, okay, well, what kind of sites are on this interface? What kind of peers are sending this traffic? So that's actually a great use case. I have a couple different customers that do this where they have really large cores, and they'll have a backbone link that yesterday was running at 50%, and today suddenly is running at 100% or 99%. And with a traditional kind of visibility tool, they have no idea what's going on. They can see the bytes on, through SNMP and some other things. And with a traditional BGP tool, they might be able to say, oh, well, it's some AS path or something. But what is actually in that? They can use this. They go select an interface, select that backbone interface, and then they can go see what sites are on this or what CDNs are on this. And chances are it's some large site or some CDN that has shifted traffic from one peer to another peer, and now it's taking a new path through the core, a new path through the backbone that they weren't anticipating. Right.
Very cool. Thank you.
Yep.
Question, how did you get all the interfaces in here, the ones that you were showing in the list?
Yeah, so that's all through SNMP.
Okay.
So once you add a router, we put in like a read-only community, and then we'll actually go and do an if index walk, pull in all the interfaces, and then now we have all of your different interfaces in there that we can go look at, right? And so not all interfaces will export flow. You have to explicitly configure this interface and those kinds of things. But we'll have actually the SNMP statistics for all those interfaces.
Is there some case that, for example, DNS encrypted? For example, it's possible to make this? Because I believe that the increase, some people or some companies using the DNS encrypted. So
yeah. That's okay. So Cloud Genome so we understand the endpoints that are delivering traffic. And so if that endpoint belongs to a specific site or a specific CDN, it doesn't matter whether DNS is encrypted or not. Now, DNS that's not encrypted from a DNS resolver that they're giving us traffic, that's additional information we can use on top of Cloud Genome to help us peel out some of the shared CDNs like Level 3 or Akamai and some other ones, right, like that. But it's not mandatory. DNS isn't mandatory for us to get this visibility. So you could give us just NetFlow, BGP, and SNMP, and we'd be able to, actually that's what this has. This doesn't have DNS. This deployment here doesn't have DNS. And you'll be able to get that same information out. Now DNS gives us an extra bit of information for the long tail of sites and services that maybe we can't identify through various CDNs, right? So like Akamai delivers all kinds of stuff. So, yeah. Real quickly, do you guys want to see the API real quick?
Sure. Yeah.
Okay, I can show you kind of quickly what the API looks like. So the API is really, really easy to use. You can just enter in a URL. And if you wanted to do this through like a Python script or a curl or something, you could add in an API key. But it's literally as simple as saying something like your URL, and then tell it you want to use the Cube API endpoint, tell it what context to use, tell it what format. So here I said I wanted to get a time graph. And then I just specified a couple dimensions. So I said time graph and CDN. I could change that really easily, right? I could do that to, let's see, peer.remote. So if I want to change it from CDNs to peer.remote, I just change the name of the dimension and rerun it. And there are all my peers.
You have the API documented?
Completely documented. Yep. Yep, and I actually created a cheat sheet for it too, because I like cheat sheets, so I got a couple page cheat sheet. It's really easy just to do a, like let's say you want to do a JSON format, right? All I did here is change the format from time graph to JSON. Boom, I hit return, there's my JSON, right? You can type CSV, data table. You can actually get some of the big data visualizations out as well. So this allows our customers to embed this data into applications, their own big data warehouse. I have customers that embed this in their own kind of customer portal, like, hey, Mr. Customer, log in, see your traffic because you're a customer of mine, those types of things.